My name is Tim Anglade. I work at Apigee, and here with me today we have Brenda Jin.
Hi, I'm Brenda Jin. I'm a UI developer at Macy's.com.
Cool. And so we're going to talk about Google Glass today and hopefully cover the topic, answer all your questions about it. We're going to have a bit of slides, a bit of biz talk. We're going to have a live demo, some coding, and some Q&A at the end. And so hopefully everything you guys were expecting from today. You know the webcast. You can see all our archive at youtube.com/apigee if you want to see old ones. And this one will be posted very soon after we get going. Obviously, there's also a slide share for all the presentation. We upload a slide as soon as the webcast is over. So go back there for archives and look for the slide we're using today. There, all the links are clickable, so you can follow along. All the example we're passing out, code examples, everything. As I said, most of us are going to be doing this webcast today. You can follow us on Twitter at those respective handles. So you guys may know me. You've seen me in a couple webcasts now. I'm old hat. You're used to me. Let's talk a little bit about you, Brenda. So what do you do? How do you get into Google Glass?
I do work at Macy's.com, and what I work on at Macy's.com is tablet prototyping. So creating interactive HTML, CSS, JavaScript prototypes to put in front of users and test in an A/B format, really rapid iteration there. I've always been interested in connected devices and how devices can help us connect with the world around, not only with each other, but the world around us. And I became the Google Glass Explorers after my team and I won a hackathon I think it was in May.
Okay. And winning a hackathon is kind of like a bad habit of yours, because that's how we met, actually. You came at an Apigee event in San Francisco and you won that competition. So apparently you're on a roll. Is this the only two you've won, or have you won more of those?
That's it.
All right. That's good enough. That's good enough for one person anyway in a single year. So yeah, you have a very interesting background in terms of technology. You're more on the UX side of things than design than maybe most of the guests we've had on this webcast so far. And it was very good to see you working magic at those events and definitely see the samples. One of the fun things about Brenda is I was doing some research for this webcast, and I typed in Google Glass example HTML5, and the first result is her code on GitHub. So you have at least one of the good local experts about what we're going to cover today. We're going to start with an overview. We're going to talk a little bit about what is Google Glass, what's the thing you need to know about it in terms of hardware, software, features, design patterns, that kind of stuff. We're going to move on to talking a little bit about building apps for Glass, what it means. Brenda is going to show us a nice demo of example interaction with Google Glass, picking information from sensors, etc. And we'll talk about kind of next steps. Are the companies already using Google Glass in their plans, already have apps out there, or are about to get apps out there, and kind of what you need to do to prepare for that on the API side and other kind of development concerns. So I'm going to pass it over to you, Brenda, at this point.
Okay, great. So let's start off with a little bit of an overview. Google Glass is this really awesome wearable computer. The reason why I decided to get Google Glass was not... I was really interested in the interaction. So it's a really different type of interaction than what we have on touchscreen devices, which has been the predominant paradigm of mobile computing. So I wanted to see what happens if you don't have that touch screen right in front of you, that little handheld flat device. What would that look like for the person using it, and what kinds of opportunities would it open up for apps and technology?
Right. Because the big thing is that we think about mobile phone is pretty mobile and we're used to them and everything like that. But this is a big switch, right? When you go from mobile to kind of wearable of you don't touch what you see, and you interact with stuff differently. It's a lot more pervasive, it's a lot more contextual as well. And so lots of nice changes in there.
So there are some really cool hardware features on this device. There's a little screen that's projected. There's a camera, a touchpad on the side right here, and you can swipe forward, back, you can tap and swipe down. There's a speaker, which is actually a bone conduction speaker. It vibrates against your skull right by your ear. And there's also a microphone, which is the sensor that allows for the voice recognition for some of the commands, like sending a text message or getting directions. GPS is through your phone, but it's because it's tethered to your phone, you can access location. The device itself is not a cell phone. The calls that you receive and send are through Bluetooth and tethered with your mobile phone.
So for the same reason, you don't get internet access either. There's no LTE, there's no 3G in there. You can access the internet through your phone tethering, but the device itself doesn't provide that. And so obviously the software is available out there. There's some examples, some code. The hardware is still limited to the Explorer program at this point, and not due to be released until sometime next year.
And also not necessarily finalized. So expect hardware and software updates forthcoming.
Yeah.
So here is a Google Glass teardown, not one that I've done, but one that you can get at this URL, just to show you where some of the hardware lives inside of the device. You can see with comparison to the US dime, the camera, optics, things like the speaker, the titanium frame, and the touchpad. And here is a side view as well.
And you see the battery, you see a dent it is like in there, and I guess they're still working on figuring out exactly how to make it even smaller. But I found this view to be very, very useful for people to understand, like, you don't have the same processing power, you don't have the same access as a phone. You really fundamentally have to think about it as a different thing, a different experience. It doesn't just look different, it's built differently, and it's very important to see that in the inside and kind of really get that.
Yeah, and you can also see that the battery is really close to the bone conduction speaker, so you want to pay attention to the type of computing that you're doing with these apps. When the battery gets hot, you will feel it by your ear, and your ear is pretty sensitive. So that's something to pay attention to for your users.
Yeah. Performance optimization matters for a whole different reason than usual. Yeah.
Some of the software features that are included in the current operating system are notifications, which are really cool. Some cards, so similar to the Google Now cards that you might see if you have an Android device. Directions is really awesome. You say, I can tell you how I would do it. So I would turn on the device and I say, okay glass, get directions to... Oh, I would have to be connected to the network, but then I would say Apigee, and it would give me some options to navigate to Apigee. And then photo and video, as well as some social sharing features with the apps that you decide to connect. So my favorite apps so far are texting and emailing. I love getting my text messages on my device, especially when I'm out to meet somebody and I'm walking around on the sidewalk. I don't have to pull out my phone and be looking down. I can look at where I'm going, and if they text me, it comes in, and I can see they're running 5 minutes late, or maybe they're 5 minutes early, or where are they right now. I love using Google Glass for biking directions. I think that the experience is even better than some of the navigation, the in-car navigation systems, because it is automatically off, and it lets you know right before turns, which is the most relevant time to know what you're supposed to do. At first, when I was using it, I was really nervous about whether it was going to be accurate or consistent, but after I used it a couple times, I realized that it was very accurate and very consistent. So now I'm very comfortable letting it just tell me where to turn, and it knows which bike paths to direct me to. Another one of my favorite features is the Google Now search. You can do a music search through the device, and sometimes when I'm at lunch and we are talking about something and want to know more, we just look it up.
And the nice thing about those examples is really, I think it really captures kind of the big design patterns for glass applications. It's really built on this idea of card and this idea of notifications. This is your very contextual data where you get the information to turn right at the right moment. And it's fundamentally different experience, at least from a UX standpoint, than your mobile phone app, where you're thinking in terms of screens and buttons and transitions. So much more synchronous, even it seems, in terms of the way you want to deal with your app. You're not going to capture the attention at all times. It's more going to be like event-based and card-based for sure.
So let's talk a little bit about creating great experiences with this wearable device. So like we said, Google Glass is not a mobile phone, but it is extremely mobile. Your screen real estate is limited, so you're not going to be able to show as many words as you are at one time as on the phone. You want to make sure you consolidate what you have to say. And like Tim was saying, the best experiences are contextual and they're relevant and they're quick. This is important because there are certain limitations. You saw how small the battery is. So battery power is really important. If you were just to use the device and have it on 100% of the time, it would not perform very well because the battery would die quickly. That's another reason why you want to keep your interactions relatively short and compact. The other reason that I've experienced is that my eyes get dry when I'm looking up and trying to read something really small on a small screen. It might be because I wear contacts, but I strongly prefer the interactions that are very quick and relevant to what I'm doing.
And what I've seen happen for battery power now is people have gotten into this habit of getting like a battery pack connected, just like you are on the cable right now for people seeing the video. to kind of keep the device, running longer and not have the burn on the battery.
So let's talk a little bit about developing for Glass. To give you a little more of a background, I just started learning JavaScript in January, and my background is front-end web development. So the demo that I will show later uses those skills and PhoneGap, which is an existing technology, to make an APK that you can then sideload onto the device. So the operating system is built on Android 4.0.4. So for all of you that have created native Android apps or are used to developing in the Android ecosystem, you'll find it easy to use those same skills and tools to develop for Google Glass. One of the things to make note of is that there's no store or formal distribution method yet for apps. There's a couple that you can access from the My Glass apps. If you go to some websites, you can turn certain apps on. As for native apps, there's no way for people to do it without the Android debug bridge and sideloading. So really exciting news. The GDK will be unveiled next week. Right now, the way to sideload is installing an APK file, which is how the Android native applications are packaged, and we'll see what comes out for Glass.
And at the same time, it seems like they're also going to be announcing specific plans to release the application, let people charge for their apps. Obviously not a huge market right now just because so few people actually have a device, but I'm sure there's going to be plans for that.
So right now there's two paths for writing apps for Google Glass. One is the one I've been referring to, which is more of the native model, sideloading an APK next week, maybe working with the GDK. And the other path is through web services, so using the Mirror API and OAuth, creating a web-based notification service, which is a lot of the apps that I have on my Glass right now, and it's really powerful. So one thing to make note of if you're going to be developing for Glass is that it's in beta, it's not out on the market, so expect a lot of changes to the operating system and API as Google continues to receive feedback and refine their experience not only for users but for developers and their development ecosystem. Also, like we talked about, maybe some hardware updates that could be really exciting.
Yeah.
So the cool thing, because the operating system is built on top of Android 4.0.4, PhoneGap works for this device, which I was quite pleased with, and is what I'm going to show you in the upcoming code demo.
Right. And so again, that's going to be one way of building applications. As we mentioned, just to kind of really solidify this, you could also build kind of sort of typical Android application and load the APK on the device just like you would load it on a phone. And then there's a third method we're not going to cover today of the Mirror API, allowing you to do remote development. You're just doing server code, talks to Google, and then Google sends instructions or data from the Google Glass device. So that the Mirror, we're not going to talk too much about that today, I think, but we're going to show you how to build like an HTML5 app, compile it as an APK to be deployed on Google Glass or running on Google Glass.
Yes, and if you're curious about developing an APK or using the Mirror API, Google has some great starter examples available on their website for Glass developers.
Right, and the nice thing about, again, the Mirror API is for people in the audience that may not be Java, Android developers, or HTML5 developers. They can use PHP, Python, Ruby, etc. You can just do fairly typical server-side programming with, again, a lot of those examples on the Google Glass developer side.
So what you'll need to do this at home is a Google Glass device. You'll need the ADT bundle or an IDE with the ADT plugin. I will be using Eclipse for Android. You'll need to have your Android debug bridge variable set up so that you can use the command line tools. And I will be using PhoneGap 2.7.0. So here we are for the demo. So I'm just going to start off with, here you see I'm in Eclipse, and here is my example project. That's mine, and I want to open up one that has been provided by Google just to show you. Actually, let's do waveform. So let's open up the manifest for the waveform activity example, and you'll see here that it's quite simple. The one permission is record audio, minimum SDK version 15 with a target of 15.
Right. Those will be the typical Google Play declaration you have to have to say, my app uses this and that. And the only reason why they use record audio is because this particular example actually uses a microphone, right?
Yes, that's correct. And so this line here, the launcher line, is one that I added to be able to launch this app from Eclipse. And I'll show you the phone gap example right now. So this is a little bit longer. Some of these are required for phone gap because on the interface it shows things like battery power and connection. But you can see that it's very similar to what I just showed you from the example. It's also streamlined from the generic phone gap example, so I've taken out a lot of the permissions that are not required. So let's dive into the HTML. Here's my main HTML page. This is a typical HTML page. You've got your head and your body, and I have two divs here because I'm going to show you how to get the accelerometer data and the compass data using the phone gap API. So I've got one div for each, and then some JavaScript for phone gap, and then my JavaScript right here. And
the two divs up top are just really placeholders for us to kind of just inject data in there afterwards. So doing a simple outputting of whatever accelerator and compass values Glass is reading right now.
That's right. So we're going to initialize the app, and we'll skip this touchpad API stuff. But we're going to use the document.add event listener for device ready, and then we'll have a callback on device ready. And inside of that callback, we're going to watch the accelerometer data. We have another callback, and I've set the options for frequency of every 1 second. You can get more fine-grained than 1 second. I've noticed that the device gets really hot. So let's leave it at 1 second for now.
To avoid burning our users.
It's for my own personal comfort. So here is our on accelerometer success callback function. What I'm going to do is to use the div by ID that I just showed you, Excel, and then I'm going to add some HTML. I'm going to show you the X acceleration, the Y acceleration, the Z acceleration, and the timestamp.
Right. And so again, what's happening here is just as the app starts, we just say, whenever there's an accelerator event, please send it to me, poll, at most once per second. And we say, please execute this thing, which is just outputting the values we read for X, Y, and Z acceleration directly onto our canvas, essentially, yeah.
So go ahead and run this, and I will show you a little bit more with ADB. So I have ADB set up, as you can see, and if I list my devices, that is my device right there. So that's one thing you can check to make sure debug is turned on your device, just like your regular Android development, and then connect via USB, and then you can check to see, start your server and make sure your devices are connected. If they're not connected, restart, plug it back in, and make sure you have that all set up.
So right now we have this code showing on the laptop. We're actually going to use an actual Google Glass device to run it, and we're just going to share the screen basically of Google Glass so people can see over the webcast, what you're seeing on the device.
That's right. And what I will show you is a projection through this tool called the Android Screen Monitor if you're looking for something to project over USB for yourself. So let's go ahead and run this.
That would be the default screen, right? The home screen, essentially?
Yes, the home screen. Is there an error message? Oh, here we go. So the device is starting, it's ready.
The application is starting.
Yes, and here we have the accelerometer data that we were just grabbing from the sensors, polling at every 1 second. And if you notice, this is a little bit different from the phone gap defaults because the background is black and the text is white. This is to conserve battery. Another thing you're going to want to pay attention to is the sizing of the fonts. The fonts are rendered a little bit differently, probably because of the screen size, so you'll just have to play with it until you get it right. And
usually a very few words and very big font, I think, is
yes.
the advice.
Yes, but it does some magnification on its own, so you might be surprised at how little you will have to change some of the sizing.
So right now we're just doing the straight output, right, of the acceleration under X, Y, Z. So basically, you're tilting your head, and how fast you're tilting your head, but also how fast your body's moving. If you're walking around the street. So instead of just outputting on the canvas like we're doing now, you could do tons of useful stuff with that data, such as monitoring for progress on a route, or kind of figuring out if people are standing, looking at something, if they're staring at a particular object, or if they're in a car or anything like that.
Yeah, or maybe if you have a sports game, like you want to bounce a basketball with your Google Glass, you could track some bouncing data.
Cool.
Great. So I'm going to show you another example of how easy it is to use PhoneGap for Google Glass. Right here, I'm going to insert a function that's going to get the compass data and then use another callback called onCompassSuccess, and then insert the compass heading into the div that we saw earlier. So I believe it is just navigator.compass. This is a PhoneGap API watch heading.
Right. So instead of watching the accelerometer, we're watching the compass, which is going to tell us basically which angle you're facing at, north, east, southeast, etc.
Yes. So we'll go back here and we will run that again.
All right. Again, just giving it a second to relaunch the application. And here we see on top of it at the bottom, you see the compass heading, right? So 360 degrees, direction you're looking at. So that could be very useful if you're trying to do some testing, for example, where people are looking at in a store. If they're facing a particular direction, or again if they're navigating, which way they're heading, or which direction they're looking at least. And you can correlate that with the accelerometer to see if they're facing the way they're heading, for example.
So I will show you some of the demos that Google has released using the same data or similar data as I just showed you right now. So if you want to install these on your own, what you can do is go to, for example, the GitHub example that they have, the APK Compass example. You're going to clone that into a local directory, and then you're going to import it into Eclipse, and I've already done that right here. From your Eclipse workspace, you can then run that application. But first you have to make sure that in your Android manifest, you add this line, android.intent.category.launcher, to make sure that you can actually launch this from Eclipse. You're going to run it, and this is the same compass data that we were using before, so make sure, try that again.
So this will be a pure Java, like typical Java Android example almost.
And you can take a look at that to see how you might want to write some custom plugins for PhoneGap, but
so as you're turning around,
the compass heading, I'm turning my head, and you can see that it knows what direction I'm looking.
So we're seeing the frame rate. I mean, I'm assuming it's looking a little bit more fluid in your eyes. Just the remote screen share that's kind of a little bit laggy.
Yeah, the USB has some latency, and I'm sure then over the webcast there's additional latency. But it's a very smooth experience from what I'm seeing.
Cool.
Great.
Awesome. So it gives you kind of an example of how the patterns don't necessarily change too much and how easy it is to kind of get something simple up and running. But so the other thing that you see is kind of your really limited real estate, the way like the application are framed are very, very simple. And again, that's not just a design pattern that they decide, apps should look like that. It's just you really have very few pixels. I mean, the resolution is crazy small compared to like Retina screen or anything like that you may be used to for mobile development.
It is surprisingly pleasant to look at, though. Before I tried the device, so I have to have contacts on. I'd only tried the device without my contacts, and I can't see like 1 foot in front of me, so I really couldn't see the screen. And finally, when I got my own device and I had my contacts in, I was pretty blown away by the depth of color and what I could make out on such a small screen.
No, quality seems to be pretty good. Yeah, amazing. So yeah, all that code, very nice. Again, the Google results should get you there if you just type Google Glass PhoneGap, but fantastic repository with examples, step-by-step instructions. If you want to build like a very simple application just using HTML5, JavaScript, and a really good wrapper to get started. As we mentioned, you don't need the actual device if you want to try to debug and try to make it run, I believe, but obviously, you're not going to get the full experience. You need to be in the Explorer program, though, to get access to the virtual machine.
Yes.
That's the catch.
Or to the physical device.
Yes, exactly, yeah. But the code should be readable, and if you have ever tried to build an Android application or a PhoneGap application, you should be able to find your way around some of those examples.
Yes, and in the example, I've gone ahead and set up the manifest for you, as well as the CSS attributes that will get you the right font and close to the right size that you might need for your application.
All right, so I'm going to take it back over try to talk a little bit about some of those examples. So I know we're getting a lot of questions too, so I'm just going to open discussion a little bit, show you some examples of what people are looking at doing or currently doing with Google Glass, get everybody's mind going in terms of use cases. We'll make sure we have time to go over all the questions I saw popping in the chat window and Q&A and make sure we cover all those topics. Again, the big thing to remember is you're not dealing with a mobile phone, not a mobile device the way you've thought about mobile so far, right? The screen is smaller, battery is smaller, you got to be much more contextual. The UX is fundamentally different, and we're going to talk about that quite a bit in terms of the examples. But from a coding standpoint, we just showed you the HTML5, the Android code, the basic patterns of watching for events, for example, in JavaScript, and triggering something. That works, right? So you don't need to worry too much about changing your code patterns. So the thing you have to remember for most use cases out there when people are just traveling, when you're not over the Wi-Fi that's embedded, you are relying on your phone. So you can finally keep your network patterns going the same way. You're dealing with the same latency, and so all your API calls to remote services, web services, etc., they're going to work pretty much the same. You're not going to have additional constraints on that in terms of bandwidth or in terms of latency. And so again, nothing major is going to change on that front. What's going to change is what you're going to want to transport on those applications. So what we've found is that typical data you want to send over Google Glass is fundamentally different. It's very event-based, notification-based. It's very contextual. It's the right piece of information at the right time for the right user. Your API may not look very different from a mobile app API, for example. But the type of data that you want to send to the user may be harder to compute because you need to personalize it for that particular moment or for that particular person or both at the same time. Or it may be type of data that you've never really thought of sharing before. And so we'll talk about some of the examples, and you'll see that there are some silos that are opening fundamentally in terms of the data that people want to use inside a Google Glass application that you wouldn't consider to make available because your desktop apps or your mobile apps don't really have any use for it. But Google Glass makes it very interesting to start using that data your company may have. I think in general, the code barrier is so low that there's not a huge technical challenge the way people may have seen with mobile apps, for example, where it's kind of like you have to change something about the way you do data and the way you relay it. Google Glass doesn't have the same barrier in terms of coding. You don't need to change your patterns so much if you've already used to mobile applications. And so from an infrastructure and code standpoint, I think it's just kind of a greenfield thing where you can have the tool, you can have the knowledge, and you can kind of get hacking on it. The bigger challenge will be on the UX side, but from the code and infrastructure, IT standpoint, it shouldn't be much that changes really. So some examples, Buzz is there. Just yesterday, Gartner came out with this press release, saying that they estimate about at least $1 billion will be saved by Google Glass and devices like Google Glass that people doing repairs just have the right information at the right time. Again, the contextuality of the information. So just think about Comcast, trying to repair your service, or an electrician trying to bring back a line, or anything like that. The ability to get the data right away as you're working, figure out where the line is, have it overlaid over your view to an extent, very critical. And this thing that there'll be direct savings on that in as soon as 3 years.
Some of the cool examples I can think of with regards to that kind of hands-free, contextual, relevant computing are surgeons or doctors that need to, in kind of a sanitary environment, that might need information or need to work with a computer, but that want to decrease the risk of contamination by not using their hands. Yeah.
Anytime basically your hands are busy and you need to manipulate tools or can just watch out for yourself, it's the same kind of advice. Yeah. Retail is another one. People think about that. There's examples for big companies just managing inventory, right? Being able to track where objects are or tell people where objects are in your warehouses. But there's some examples for consumers as well. So it's a nice story I found very recently as well of somebody just looking at objects and being able to ask Glass to figure out what material, what color it is, or similar objects that may go well with that object. So as you're shopping, that kind of contextual information about potential commerce opportunities could be very interesting. Construction, very similar maybe to repairs. This idea of being able to overlay blueprints as you're building something and figure out where the line is supposed to be drawn, figure out if everything is where it's supposed to be. Nice tool, at least for architects, for construction managers, and definitely some people are betting on that and already trying to build application for this kind of very old, not necessarily very digital industries, at least in the way that we think about it in Silicon Valley. I saw law enforcement examples, which of course, the trend has been recently to have a lot of wearable cameras that officers wear for legal reasons or for their protection or for a number of different trends. And so obviously Google Glass, kind of the forefront of that. There's this nice write-up about a unit in Georgia kind of testing it out for situation like arrest, even in pursuits and shooting, kind of figure out how the device holds. This is where I got the tip of people actually just basically hooking up a battery pack to the early version of Google Glass to keep it running and keep it running not too hot. So, just again, kind of some examples of where you could see the technology becoming very pervasive, and much like segways, I think the nerd or credibility factor is not too much of an issue when it's a big burly policeman kind of wearing it. So it should be pretty good. Healthcare, you mentioned it. So obviously a very big kind of area where maybe even the price of the device maybe not too much of a concern. A host of different use cases. So actually your friends at Accenture made this really nice video. They were showing it at the conference last week as well in terms of surgeons, doctors, anesthesiologists, and kind of how you can deal with information contextually with patients in very time-sensitive kind of scenarios. Of course, that's not just enterprise use cases. There's tons of consumer use cases. My favorite one so far is this kind of prototype that they're trying to build. I think it's a company in the UK of allowing joggers to basically have this kind of ghost version of themselves. So as they're running the same route, every day or every week, they can kind of see how they're doing, and it's overlaid over their current vision. So that's just an example of how even existing application can be fundamentally changed with Google Glass. You wouldn't have that kind of use case on your phone because joggers wouldn't have their phone in front of them at all time while they're running. But this is kind of a cute, nice way of maybe motivating yourself, and really something you can do without Google Glass before. Another quick one, kind of less invasive, less in your face, but this idea of you're wearing Google Glass, maybe you're wearing it all day, and as you're traveling around parks or the city, you can say, what you're looking at is this, and you may want to go there and see that as well, and it kind of really helps augment the experience rather than overtake the entire experience.
So an example of this is I was recently in Madrid, and I bought a data plan while I was in Madrid, and this is the first time ever that I've had an international enabled device, data plan abroad, and I went to Toledo, and I went into a church, and I saw this painting. And I thought, I know there's something really significant about this painting, but I just can't, I don't remember, and I left my tour book at home. So I looked it up. And that's one of the cool things you can do, just like you can look up Old Faithful, you can look up the art, find out why it's significant, and even if it's not with image recognition, you could give enough words to be able to pull it up very accurately right when you're there and learn about what you're looking at.
And again, it's not just like the use case where you could do today to the phone where you're in a museum and you consciously look something up, but you could be alert of something you're looking at that's actually very significant that you may not otherwise have noticed. So again, this idea of event and notification takes an even newer meaning than what we know about mobile applications. So some good stuff going in there. That's just some stuff, some examples. There's tons of apps coming out, and tons of prototypes and ideas online. But to give you a sense of kind of the breadth of different options that you could be looking at in terms of building application use cases, industry that may be interested, from very niche markets where maybe just a few surgeons will need the application, but would be willing to pay a lot of money for it, to mass consumer application once Google Glass comes out and maybe the price comes down a little bit. So the big thing that they have in common, the reason I feel like they're so exciting is that they really put the UX first and they really think about it as a fresh thing. One thing Google tells you on their Glass developer pages, think of it as its own thing. Don't try to port your app over. Think about the canvas, just fresh. Just start completely empty. So that's really what I would recommend people do, is really start from what is the experience I want the user to have, and really think about that first. And you'll see that it may not look like anything like what you're currently offering on the App Store or the project you may be thinking of putting on the App Store. Then you'll move about thinking about the data you need. And you may already have some of that data available over an API, and you may be able to integrate very directly. But the use cases are so different. I think you'll find that you'll need to kind of open up new silos and get access to more of the data, or contextualize it in a different way. Really correlate it to the user, to the location, and query it or rejigger it in a different way. The making it happen part, I think, actually is going to be the easiest. The code patterns are decently similar. There's not a major obstacle there. So again, if you already know mobile development, you're familiar with API, you're familiar with kind of keeping an eye on the battery and using sensors, etc., I don't think it's going to be a fundamentally very different experience for you, and I think making the app actually happen is going to be very easy as long as you start on the right foot in terms of UX and thinking about the data that needs to be used in the application. All right, so I know we got tons of questions, so I'm gonna stop here and make sure that we cover all that stuff. So let me see. All right, a very direct question. So what does email look like on Glass? Do they have image? Do they have colors? Do they actually kind of relay all that stuff when you look at emails?
So I don't see the attachments, but I get the first, I think, a couple hundred characters of the text. On the first card, I get probably like 3 or 4 lines of text, and then I can read more or have it read aloud to me.
So they use the voice kind of a lot for that, and it's really not meant to be like, I guess they do it on purpose, not showing images or anything like that, and keeping the colors off.
The colors that I've seen are for the avatar of the person. So if you have a Google Plus image of yourself, I will see it associated with the email because that's who you are, and it allows me to easily identify who is sending me the email. Okay.
But again, like more of a visual confirmation kind of thing than like a full detail kind of a picture. Julia is asking, is there any documentation on API and ROI features and roadmap? So I haven't seen much being very publicly disclosed like in advance. I do feel like they've been kind of really good at showing people, giving people a sense of where they want to go with this, and trying to keep things relatively stable. I mean, we're not talking about major rewrite and your application won't work, but just like any platform, some calls deprecated, some calls get added, and that's pretty much been the pattern. Is there a good place, a Google developer website probably?
Yes, and let me tell you the URL right now because I have it up. It is developers.google.com/glass.
When would you recommend using the Mirror API versus the JDK? One of the last question from Panayotis.
That's a great question. So definitely if you're interested in using a lot of the hardware sensor information to enhance the experience of whatever notification or interaction you're trying to creating, then using the GDK. If you're going to do more contextual notification, I definitely recommend the Mirror API. One of the cool apps that I have right now through the Mirror API is an app called Fancy. I actually first heard of them because they do a really cool tablet app, and their app looks amazing on my new Nexus 7, and they were in the tablet spotlight. So it's a cool shopping application, and today I got a card, and I could look at a couple things in my Fancy feed, all through the Mirror API, and then actually purchase them or like them.
Right. So the pattern for coding there is pretty similar, as far as I can tell, to the push notification pattern that people may use already for their mobile apps. Of most of that logic is end of server side. Maybe you do a bit of geofencing, but that's not actually triggered necessarily from your application running on the phone. It's like a server process running, and so that would apply as well for anything like that. You probably want to use a Mirror API.
Yeah.
It seems to be a little bit more full-featured, than maybe what you would think of doing over push notification for a mobile device, but the pattern would probably be the same. So let's see, what else do we have? What does Cordova and PhoneGap facilitate over using pure native constructs? So very easy to take. This one is just it just kind of lets you use HTML5 and JavaScript, and as this unified API, you may want to reuse some of that code across other platforms. So in the case of Google Glass, there are not really a lot of other competitors right now. But the big advantage of PhoneGap for mobile is you can write the same code once, and it works on iOS, it works on Android, etc., etc. So maybe as Samsung and Apple and others, have some Google Glass type products, it will help you kind of bridge all the differences with a nice clean API in HTML5 and JavaScript.
It's just another tool for you to use. There's benefits and disadvantages of every tool out there, and for me, it was one that I could just pick up and use right out of the box.
And then there was a question about using your iPad and iPhone with it. That's possible, right? They're just communicating over Bluetooth.
It's possible. I'm not sure if you'll get all the features if you tether it to an iOS device. I know that I get all the features because I have an Android device.
We have a question from I guess Matthew or Jibin about facial recognition. So as far as I've heard, yes, it's they don't encourage that at all, and they tend to block you if you try to make apps that do that.
Yeah, I think there's something about facial recognition in the policy. Also, I would be interested to see a facial recognition, image recognition application that actually works outside of Glass first.
Yes, it's a good place to start with.
So, if you can do that kind of computing, please send me a link.
Yes. So I know somebody was sharing a link in the chat window about some example apps. I know some people have tried, and it's an APK. You can grab it and try to load it. But there's no endorsement from Google, nor facilitation to do that. There's no face recognition API built into like the Android SDK that they use for this, or anything of the sort. So Elizabeth asking about cost. Your guess is as good as ours, Elizabeth, on this. They haven't said anything. Right now it's about $1,500, I guess, for the Explorer kit. And
plus tax.
Plus tax. But they give you a champagne glass, I hear, when you go pick it up at a Google office. So that offsets it a little bit. And yeah, people are kind of aiming for, think that they're going to aim for 400, 500 when it comes out. It's more of a wish than anything. I don't think anybody from Google has ever said anything about that. But analysts tend to seem to think that this would be like the nice price point for it. Is there an OCR or Q code API, anything for barcodes or from text detection?
Oh, yes, there is QR code detection. I haven't seen an app for it, but that is actually how you can do some of your Wi-Fi configuration.
Oh, cool. So it's built into...
So as you're tethering to your phone, if you have to enter a password for some networks, it'll generate a QR code, and then your glass will know to try to scan the QR code.
Cool. And then the other thing somebody was asking was security consideration and requirements. So, what I've seen about that is it seems to be that a lot of the features tend to rely on stuff being continuously uploaded to Google. So when you take pictures, that they end up directly on the cloud server, etc. And part of it is to avoid kind of like memory limitation on the device itself. And so that seems to be a concern that people kind of tend to take very seriously. So we'll see exactly how that happens. I'm sure there'll be possibility of like kind of blocking that behavior for enterprise application and kind of keeping the data as local as you need it. Outside of that, it tends to be more behavioral or larger sense security. People are concerned about the camera capturing passwords as you type in on your keyboard, if you look at your keyboard, or watching you type a code on a pen pad, those type of things.
So I can address some of that. If I wanted to capture your PIN or your password, I personally wouldn't wear the camera on my face. I would probably hook up one of those little, those little teeny tiny Arduino sensors that you can disguise really easily in an item of clothing. Hide the wire, sew in the wires and hide it around the back with some really great battery, and capture it that way. So it's pretty obvious that the device is on your face. So it does alert people to the potential that you could be engaging with the device versus a more concealed surveillance device.
Yeah, and I think the pattern that people are kind of worried about is like forgetting you have it on and then capturing your own password maybe, or capturing your own like PIN code as you type things. So we'll see exactly how that's addressed. I mean, the device is off for most of the time, right? And it's just in waiting for instructions. So how much of that is just FUD versus actual concern that CIOs or other parties will have? We'll see exactly how that happens. It's kind of a brand new world and hard to figure out, but it's not unlike some of the concerns you may have heard about cell phones and like everybody's going to start capturing movies in the theater and like record concerts, and that ends up not being a big concern most of the time. Zalmi's asking about distribution of applications and monetization. So I'd be very surprised if Google didn't come out with a way for you to distribute this through Google Play and charge people for your applications. I don't know how soon that will happen though, because we're not looking at a release until 9 months from now, kind of roughly, more or less, is what they seem to be indicating. And I'm not sure how big of a market it will be right away. It will depend on the price point. It really depends on how many people actually go and buy it. So I do feel like there will be a high-end market, for surgeon, for those kind of application, for construction, for industry. That's probably more reliably true than a mass consumer market. I do feel like a lot of buzz is going, and so it's not it's not unlikely that it will be like a huge consumer success, and there will be a huge traditional app market for that as well.
So I can talk a little bit more about how to get apps into the glass. So yes, side loading is one way for the APK files, but the other way is through the Mirror API. Via the web, you can actually activate some of the Mirror API apps. And then in your My Glass application, you'll see a list of some apps that you might be able to activate for your device, and then it'll take you to a website where you can authorize it.
What would be the media transfer method? Michael's asking. So I'm assuming, if you need to send like a video or pictures or anything like that. Have you seen any of those examples?
Sharing video or
So I'm
so with social
assuming
network?
for sharing, I know for the sharing, apparently your video, if you can record it, save the file, and just kind of upload that the way you would from a traditional device. You can also do some live hangouts, right? If you want to live feed your camera to an audience. I've seen some example of that. In terms of loading like images and videos, I'm assuming it works just like a natural app if you want to display a video or an image.
Within an app or
within
just
an
on the
application.
device?
Yeah, either one. Actually.
So I haven't tried it within an app, although I'm pretty sure there are examples out there if you look on GitHub. As for the device itself, if it's a video that you or image that you've taken, you'll see it in your feed, and then you can share it depending on what apps you have activated. So Twitter, Google Plus. I'm not. And then if you plug the device into your computer, it's just like plugging your phone into the computer, where there's kind of like this camera feed, so you can physically copy the files over. I'm not sure what would happen if you try to physically copy some files the other way. That would be a fun thing to try later.
I think that's it. Again, thanks everybody for joining. Let me just give you again links to keep the conversation going on API Craft for anything API related, and App Craft, a recent group we started for app development, including Google Glass. If you have any question about that, and so please do ask questions, follow-ups on there, and we'll be very happy to interact with you. And that's it. Again, you can find Brenda at Cybernetic Love on Twitter. I'm at Tim Anglade on Twitter. And we hope to see you on another webcast really soon.